This is a recording of topic 13-6, multiplying polynomials. Our objective for today is I can multiply polynomials. In your topics packet, you'll need to find topic 13-6 and look at the top of it and complete the bell work. Our bell work for today: each of the following tables contains an element of an x and y relationship. Which table contains 4 points that cannot lie on a graph of a function of x? So we need to be sure we are understanding what the question is being asked. It's asking for the table with 4 points that cannot lie on a graph of a function of x. So take this time to look at your answer choices and make a selection. You may pause the video for a moment before going on and finding the answer. So if I'm looking for something that cannot lie on a function of x, then that means what I'm looking for is something that is not a function. Because if it did lie on a function, then I'd need a function. So I'm looking for something that is not a function. The way that we tell if you have a function is we're looking at the x values. To be a function, all your x values have to be different. If it's not a function, then what my class likes to say is your x value is cheating. That means you have an x value that repeats. It's repeating. So if I look at our first table, I like to write them going up and down, so I'm going to rewrite them because it helps me see the cheaters. My first point is 0, -1, so the x is 0, the y is -1. Then we have x is 2, y is -2, x is 3, y is -3, x is 4, y is -4. I can look at all my x values and see they are all different, so there are no x's that are cheating. That means that a is actually a function, but what I'm looking for is something that's not a function, so that is not my answer. Let's look at b. If I look at b, again, I like to see mine up and down, so I'm just going to do a quick rewrite. X values, y values. My x values are 1, 2, 3, 2. I hear my little bells going off. My y values are 4, 2, 2, 4. I can see I have an x value that's cheating. My first x value is going out with the number 2, and then I have an x value of 2. That same x value is going out with number 4. This is my cheater, and when you have cheaters, you are not in a functional relationship. Therefore, you have b that is not our function. Let's go ahead and check C and D to make sure all our x values should be different. So C has -1, -2, 3, and 4. They're all different, so it's a function. D, we have 0, 1, 5, and 6. They're all different, so it is also a function. Now let's look at our notes for today. We're going to be multiplying polynomials, and actually, more specifically, we're actually going to multiply a monomial times a polynomial. So remember that a monomial, it has letters and variables, but there's only one term. The parenthesis tells us that we are multiplying, and this time we're multiplying by 3 terms. That's called a trinomial. So it has more than one term. So let's multiply. The way that you're going to multiply is this monomial on the outside has to multiply everything that's on the inside. So I am going to draw my line showing what's being multiplied. I got the 3x is going to multiply times the x squared. Then that same 3x is going to multiply times the -x. And that same 3x is going to be multiplied times the 2. So everything inside the parenthesis has to be multiplied by the 3x. So I'm going to show my work. My 3x is on the outside. It's being multiplied times the x squared. That's my first one. Then I'm going to do plus. I have a 3x again. It's going to multiply times the -x, or -1x. I'm going to put a 1 there so it reminds me that is a number. And then I'm going to add that to our 3x is multiplying times the 2. So first I'm going to multiply, then I'm going to combine like terms if possible. So let's look at our first one. We have 3 times x squared. We have 3x, and then x squared, that's like x times x. So this is me showing my work. Plus, I have two terms being multiplied. Let's recall what we did before. We're going to take the numbers and rewrite them. So it's the 3 times -1. I have my numbers out front, and then I have x times x. Plus, again, rewriting with numbers out front, we have 3 times the 2, and then I have an x at the end. So now we're going to simplify and rewrite it. Our first term, we have 3, and then we have 3 x's, so it would be x cubed. Plus, I have 3 times the -1, that's -3, and then I have 2 x's, so that's x squared. Plus, 3 times 2 is 6, and I just have 1 x. Notice that I cannot add them because in order to add, I have to have the same variable with the same exponent. This has x cubed. My second term is x squared. My last term is x, so I cannot combine them. But what I will do is rewrite it. Instead of having plus and minus, we're just going to, or plus and negative, I'm going to write it as a minus 3x squared plus 6x. On a standardized test, multiple choice, this is what your answer will look like. If I just have you show your work and short answer, right above it is also correct. Keeping the plus and negative is also acceptable. Let's do number 2. Again, we start with what's on the outside. It's a -2x. We're taking that whole quantity, and then we're going to distribute it. So -2x times x squared, -2x times a -4x, and a -2x times a 6. I want you to take the time to actually write out the second step where you show your work. So let's show what's being multiplied. We have a -2x times our first term is x squared. We're going to add it to, we have a -2x times our second term. Remember, take the sign with it, -4x. And then combine it with -2x times a positive 6. Our first term, rewriting, I have a -2, I have an x, and then from the parentheses I have an x and an x, or an x squared, so I stamp it out twice. Plus, let's rewrite it first. Let's start with our numbers. We got a -2 times a -4. Then we'll follow it with an x and an x. Then plus, I have a -2. I'm putting my numbers first, times a positive 6, and then an x on the end. And notice how I am crossing them out when I rearrange them. So now let's simplify. We have a -2. There's no other numbers that's being multiplied, followed by x times x times x. So we're going to write it as x cubed. There's 3 of them. Plus -2 times -4. That gives us a positive 8. And x times x is x squared. Plus a -2 times 6. That's a -12 with an x on the end. Again, we've gotten to a place where there are no terms that we can combine because they all have different variables with exponents. So I'm going to rewrite it because I have this plus and negative. So we get -2x cubed plus 8x squared minus 12x. It's our final answer. Notice when we're multiplying, whichever term has the most, or whichever polynomial has the most terms, that's how many we're going to end up with. So I have a monomial, which is 1, multiplied times a trinomial. My answer came out to be a trinomial. So one way that we can remember this is when there's a monomial in front, it's the same as distribution, and make sure you draw your rainbow so that you see you're multiplying everything inside the polynomial, or everything inside the parenthesis, by the number that's on the outside, or the monomial that's on the outside. Hence our rainbow. We have several arcs, not just one. So our next examples, you'll see my little hint down here. We're going to do a rainbow, and then we're going to stack them, because now you see that there's more than one thing there that we are going to be combining. So we still have a monomial. This is a 3 times this polynomial inside the parentheses, so that means we do have to distribute. But now we also are going to combine it with yet another monomial. We take the whole thing in -2 that is also going to be distributed. So we're doing two distributions. Let's start with the first one. We got 3 times 7x and then 3 times a negative 5. Our second one that we're going to combine with is negative 2 times x squared and negative 2 times a negative 3. So let's write it out. Our first one we have 3 times the 7x, takes care of our first arc. We're going to combine it with, so let's put a plus sign, the 3 times a negative 5. I take the entire sign with it. Then we're going to combine that with the negative 2 times x squared, and then combine it with, so I'm using plus to show I am combining a negative 2 times a negative 3. So my second arc. Now let's simplify. 3 times 7, that's 21, and we have an x. Plus 3 times a negative 5, that's a negative 15. Plus negative 2 times x squared, that gives us a negative 2x squared. And then plus a negative 2 times a negative 3 is a positive 6. So we've taken care of the rainbow. Now let's see, can we stack them? Are there any things that can be combined? So I'm going to start off with the first term. Or let's start off with, when we do combine terms in our final answer, we like to have the biggest exponent first. So let's start with the term that has the biggest exponent. First of all, notice that I do not have any more multiplication going on. Everything else is just combining. So I'm going to start with the negative 2x squared because it has the x squared. So I'm going to put that first, negative 2x squared. Took the sign that's with it, so now it's gone. I don't have any other x's, x squareds. So now I have a 21x. It goes in the second column, 21x. I'll cross it out. No more x's. Now let's look at our constants. I have a plus and negative 15, so I'm going to put a negative 15 in my last column. No variables with it. And last, I have a plus 6. I'll put it in the last column with the other constant. Now combine. There's nothing to combine with our negative 2x squared, so it stays negative 2x squared. Nothing to combine with our 21x. It's positive, so we put a plus 21x. And then when I do negative 15 plus 6, you can type that in your calculator, remembering that because the 15 is first, so I use this negative, I type it in as negative 15, not minus 15. And that is going to give us a negative 9. So my final answer is negative 2x squared plus 21x minus 9. So let's talk about the next one. We have 4x times x plus 6, and then minus x squared plus 1. So let's imagine, let's talk about the first one, first part of it. We're going to distribute the 4x. So 4x times x and 4x times a positive 6. Let's go ahead and write that. 4x times x, we need to combine it with the 4x times a positive 6. I've taken care of my first multiplication. Let's look at the next one. This is minus x squared plus 1. Now in the past, we've just, if they didn't have a number in front, it was just minus, that meant we stacked them up. But I'm going to show you another way that you can do this. We're still going to stack in the end, but imagine that there's a 1 in front. Because again, if the number's never shown, it's always a 1 there. So now we're going to distribute this negative 1, because there's a minus sign. So distribute, we have, again, I'm combining, so I'm just going to put a plus to show I'm combining, but now let's show the distribution. Negative 1 times x squared. And then I want to distribute it to the other one also. Again, combining it with my last term, so it's negative 1 times a positive 1. Now let's multiply everything out. We have, there's nothing being multiplied by the 4, and then we have x times x, so that's x squared. Plus, we have a 4 times a 6. 4 times 6 is 24, and we have just one x with it. Plus, we have a negative x squared, a negative 1x squared, so we put a negative 1x squared, just rewriting it, and then plus a negative 1 times a negative 1 is a negative 1. Now I want to combine like terms, so I'm going to do a little shortcut and just put a little, my lines. This line should have come in front of the plus, not after it. So I look for any other x squareds. I have a plus and negative 1x squared. I'm just going to put it underneath plus and negative 1x squared and then cross it out. I don't have any other x's and I don't have any other constants. So those are my only two things to combine. We'll say 4 plus a negative 1. 4 plus a negative 1 is going to be a positive 3. We still have the x squared. Nothing else combines with the x's, so that's 24x. And then at the end, nothing else combines with our negative 1, so I'll put just the negative 1. So our answer is 3x squared plus 2x, 24x minus 1. Let's do a couple more examples. Again, having our 2, remember, do your rainbows first. So let's see what we can distribute. I have a negative 2 that's going to distribute. It's times x, so negative 2 times x. I combine it with what else? Negative 2 times a positive 7. So negative 2x times a positive 7. Then I'm going to combine it with, that's a positive 3x times x. So 3x times x. Combine that with my next thing I distribute, and that is a 3x times a negative 4. So I have a negative there now. Let's simplify. We have 2 times x, so that's a negative 2x squared, plus negative 2 times 7, it's a negative 14x, plus negative, or 3x times x, so that's a 3, and then there's 2 x's, so x squared, and then plus 3 times a negative 4, that's a negative 12x. There's no squared term with that, just an x. Now let's see, can we combine any like terms? I'm going to look to see, do I have any other x squareds? Breaking up my terms. Okay, this is negative 14x, not an x squared. Plus a 3x squared? Yes, let me put it down below it. Plus 3x squared. I'm just copying it over, moving it. And then I have plus a negative 12x. Hey, that's another x, so I say plus a negative 12x. And then I scratch it out. This is my stacking. So I have a negative 2 plus a positive 3. Negative 2 plus a positive 3 is 1, x squared. And then I have a negative 14x plus a negative 12x. Again, using my calculator. I see they have the same side. That means I can combine them. So again, I'm going to combine it with, this is a negative 26x. Now let's rewrite. I have 1x squared. Notice my plus and negative, so it becomes a negative or minus 26x. Again, on a standardized test, you will not see the 1 in front of the x squared. Our last one like this, we're going to distribute into a trinomial and then into a binomial. Let's try it again. So start off with the 6. We're going to multiply it times the x squared. So 6 times x squared. I want to combine it with my next one. We have 6 times a negative 2x. I want to combine it with 6 times a positive 1. So I've taken care of my 6 in the first parenthesis. Now I have a, take the sign with it, negative 5x. So we're combining them together and put a plus sign, showing I'm combining. Once I distribute, we have a negative 5x times x. And then combine that with my second one I distributed to, a negative 5x times a negative 7. Again, there's a negative there. Taking the sign with the number. So let's distribute, or let's multiply it out. We have 6 times x is 6x squared, plus 6 times a negative 2, that's a negative 12x, plus 6 times 1 is 6, plus negative 5x times x is going to give us a negative 5x squared, plus negative 5 times a negative 7 is a positive 35, and then we still have an x. Now let's see if we can stack them up. We have our 6x squared. Look for any other x's. And we do have, sorry, any other x squares. Sure enough, we have a plus a negative 5x squared, so I'm going to rewrite it over here. Plus a negative 5x squared. And since I wrote it over there, I'm crossing it out. I just moved it, so it's lined up underneath, stacked up. And then we have a plus the 35x. I'm going to put it under here, plus 35x. Again, cross it out. I don't have any constants left. So I have a positive 6 plus a negative 5. That's going to give us a positive 1x squared. I have a negative 12x plus 35. Again, you can use your calculator. You'll type in a negative here. Negative 12 plus 35. That gives us a positive 23. I can't draw my numbers. And then x. And then last but not least, there's nothing being added to the 6, so we just put a positive 6 down here. So now let's get rid of our little dashes. We have x squared plus 23x plus 6. We have now distributed in combined terms by stacking them up. Before we conclude this lesson, let's do some review problems because we haven't done some in quite a while. Number 7, this is just our multiplying polynomials. Notice we don't have any exponents outside the parentheses, so all of this is just multiplication. We're going to start by rewriting, putting our numbers first, so 4 times 5. Then our variables, m squared times m to the 5th. And then we have an n left over. So now we can multiply out. 4 times 5 is 20. If I want to show all my stamping, m squared is m times m. There's 2 of them. M to the 5th is there's 5 of them. 1, 2, 3, 4, 5. And then there's still only one n. Now combining all my m's, we'll count them up and we'll get 7. So m is to the 7th power, and then we have an n left over. Number 8, we have division going on, but one of the first things I see is a variable with a negative exponent. So I'm going to go ahead and circle it. Before I do anything else, I'm going to rewrite it. So my variable with the negative exponent, I want it to be positive. So everything else I am just rewriting. But now I'm going to deal with my y to the negative 4. It was once on top. To make the exponent positive, we got to move it down to the bottom. So now I have at the bottom y to the positive 4th. So now we're going to separate again, put our numbers first, so negative 4 over 12. Then our x's, we have x to the 5th on top, so let's stamp out 5 times. 1, 2, 3, 4, 5. X to the 3rd on the bottom, so we'll stamp it out 3 times. 1, 2, 3. Got our x's taken care of. Y's are only on the bottom. Our first one is just a y. It's to the 1 power, so we show it just once. And then y to the 4th, 4 times. 1, 2, 3, 4. Now we'll simplify. Take a moment and get your calculator. I love to use my calculator to help me simplify these fractions. So this is just the same as saying negative 4 divided by 12. It's negative 4. We'll type in divided by 12. We get 0.33333 or negative. I want to see what that looks like as a fraction because I don't know how to put that. I don't like to round off. So we'll do math, enter, enter. Math tells us fraction, enter. We're telling it change to a fraction. We get a negative 1/3. So that tells us the negative 1's on top, the 3's on the bottom. Let's look at our x's. We'll cross our x's off. We're left with 2 x's on top, so this is x squared. And then on the bottom, we have y's. There's 1, 2, 3, 4, 5, so the y's are on bottom, and raised to the 5th power. It's our last one. Let's take care of any negative exponents. We see b to the negative 3. So let's put a little line. It tells us, hey, we're going to need to put that at the bottom. So 2b now is to the positive 3. Notice only the b is the thing that moved. The 2 actually is to a positive 1 power, so it doesn't change. We still have a 3 on the outside. And then we have a cubed b squared. That's wrong. It's a cubed b and it's still being squared. So now that we've taken care of the negative exponent, let's stamp out. We have a 3 outside the parentheses, so that means we need to stamp out what's in the parentheses 3 times. So 2b cubed, that's 1 time. 2b cubed, that's 2 times. And then 2b cubed, that's 3 times. Followed by, we have a cubed b. We have a 2 on the outside, so let's stamp out that 2 times what's in parentheses. A cubed b, that's 1 time. A cubed b, that's 2 times. Since what was in our first parenthesis was fraction, we can just say those are all in the top. Now let's rewrite. We want our numbers on top. So I'm going to use this line as my fraction line. We do 2 times 2 times 2. We got that from those first parentheses. Now let's look at our a's. We're going to put our a's together. We got a cubed, so that's 1, 2, 3 of them. First parenthesis on top, or another parenthesis on top, and then we have another a cubed, so 1, 2, 3. We took care of our a's. Now we're going to do our b's. So on top, we have 1b in a parenthesis and another b in a parenthesis. But on bottom, we have 3 b's. So 1, 2, 3, followed by another 3 b's. 1, 2, 3, and followed by another 3 b's. 1, 2, 3. When I simplify my numerator, it's a 2's. 2 times 2 times 2, that's 8. I look at my a's. There's 1, 2, 3, 4, 5, 6. So a to the 6. Looking at the b's, I got one in the top and the bottom, another top and the bottom. All the b's are left are in the bottom, and there is a total of 7. So our answer there is 8, a to the 6th, b to the 7th power. This now concludes your topic 13-6 on multiplying polynomials.